Let's continue with question number 71. The question is that a famous sweet shop sells tinned rasgullas. The tin container is cylindrical in shape with diameter 14 and height 16 centimeter. It can hold 20 spherical rasgullas of diameter 6 centimeter and sweetened liquid such that the can is filled and then sealed. Find out how much sweetened liquid the can contains. Take pi equal to 3.14. So we have a cylindrical can inside which there are some number of spherical rasgullas. So these rasgullas are spheres and they are identical. So we have some number of spheres inside the can, and the assumption is that the remaining part in the can is filled by the sweetened liquid. In real life, the rasgullas will also absorb some liquid, but here we're assuming that um, what is the amount of liquid which is in the can but not really absorbed by the rasgulla. So the volume of sweetened liquid will be the volume of the entire can minus the volume of all the rasgullas. That will give me the required volume. So if I calculate that way, so the volume of the liquid is difference of volume of cylinder and the total volume of all the spherical rasgullas. Then if I just substitute the values in the formula, for cylinder volume is pi r square h, and for a sphere the volume is 4 by 3 pi r cube. R1 and R2 have taken because the radius of cylinder and sphere are different. R1 is radius of cylinder, R2 is radius of sphere. H is the height of the cylinder. Then if I substitute the values, I can also see that pi is common. So I have taken pi common. Then radius of cylinder is 7 centimeter. If diameter is 14, radius is half, which is 7. So I have 7 square into height 16 minus the number of rasgullas was 20. So there are 20 spheres. So 20 into 4 by 3 into radius of the spherical rasgulla is 3 centimeter. So 3 cube. So if I calculate this further, pi I am taking 3.14, and then this comes up to be 784 minus 720. So 3.14 into this difference is 64, which gives me 200.96, and the unit of volume will be cubic centimeter or cm cube. Moving ahead to the next question. The ratio of radius and height of a solid metallic right circular cylinder is 7:27. This is melted and made into a cone of diameter 14 and slant height 25 centimeter. Find the height of the cone and the cylinder. So first we had a cylinder, a metallic cylinder, which is melted and recast into a cone. So whenever we are melting and recasting anything, overall the volume of the original solid will remain the same for the new solid formed. So that's the equation I can make, where volume of cylinder will be equal to volume of the cone. And then given some data about the radius and height, so ratio of radius and height of the cylinder is 7:27. So we can start by saying that ratio for cylinder radius to height is 7:27. So let's say radius is 7x and height is 27x. That is for my cylinder. And then for my cone, radius is half the diameter, which is 7 centimeter. L is slant height, which is 25 centimeter. Height I am not sure, so I will take height of the cone as capital H, just to distinguish between height of cylinder small h and height of cone is capital H. Okay, then in the cone, because if you look at a cone, the height, perpendicular height, and the radius and the slant height, L, H and R, it forms a right angle triangle. The hypotenuse is slant height L. So L square will be equal to H square plus R square. So if I apply that, my height of the cone comes up to be 24 centimeter. Then I will apply in this question that when it is melted and recasted, volume of cylinder will be same as volume of cone. Then I apply the formula for volume of cylinder, which is pi r square h. Volume of cone is 1/3 pi r square h. The radius and height, I am taking different variables because it's different for the two solids. Then just substitute the values. Radius of cylinder, I assumed 7x, height 27x. So in terms of x, I will be having this equation, and then I'm getting x cube equal to 8 by 27, and I will find, if I take cube root, x value is 2 by 3. Now the question was asking height of cylinder. Height of cone I have already found out in the previous part. Height of cylinder will be 27x. So 27 into 2 by 3, I'm getting 18 centimeter for height of cylinder. Moving on to the next question. We have an inclined plane AC with base AB, which is root 3 times its vertical height BC. The length of the inclined plane is 15 meter. Find the value of theta and the length of its base AB in nearest meter. So this inclined plane situation is also simplified to represent in this triangle ABC. Angle B, we are assuming right angle. This is theta degree, and the length of the incline AC is 15 meter. And they have also given us some data that AB is root 3 times BC. AB is root 3 times BC, and I want to find theta and the length of AB in nearest meter. So if I look at this right angle triangle, I can apply any trigonometric ratio, but I'm interested in something to do with the angle theta, and there is a relation between the side AB and BC. So that's why I'm taking the ratio BC by AB in this triangle is actually tan theta. So if this is theta degree, tan ratio is perpendicular by base. So then it is BC by AB, and in this situation AB is given as root 3 BC. So BC by AB is same as BC by root 3 BC, which simplifies to 1 by root 3. So then my tan theta becomes 1 by root 3, and I also know, according to my knowledge of standard angles, tan of 30 degree is 1 by root 3. So therefore this theta angle has to be 30 degree only. Now for the same triangle, if I look at the cos value, cos of theta angle, that is the ratio. Cos ratio is base by hypotenuse. So AB by AC is cos theta. Now I am interested in the length of AB. Length of AC is 15 meter. That's the reason I'm taking cos theta, which is AB by AC. And theta already found out is 30 degree. So it is cos 30 degree, which is AB by AC, and AC value is 15 meter. And then cos 30 degree, again a standard angle, I know that it's root 3 by 2. So then if I calculate, AB value will be root 3 by 2 into 15, and root 3 value I can plug in as 1.732. That's also a known value. And if I calculate, I get AB as 12.99 meter, but the question has asked me to write till the nearest meter. So 12.99 rounded to the nearest meter is 13 meter. The answer given in the document is 8 meter, but that is not correct. It should be 13 meter according to the description in the question. Okay, then moving ahead. A question from trigonometric identities. We have to prove that tan square theta plus cos square theta minus 1 is equal to tan square theta into sin square theta. So there are some identities that you have learnt in grade 10. You can think of applying some of the identities and then get that this left hand side is equal to this right hand side. So if you start by the LHS, the left hand side, we have tan square theta plus cos square theta minus 1. Now in the right hand side, I need something with tan and sine. I do not want cos. So then I will use the identity that sine square theta plus cos square theta equals to 1. Otherwise, I can say cos square theta is same as 1 minus sine square theta. So this cos square theta in the LHS, first I can rewrite it as 1 minus sine square theta. And then plus 1 and minus 1 is cancelled, and I will get tan square theta minus sine square theta. Now the RHS has tan square and sine square, but not as a subtraction, it is a multiplication. So then I need to do something. I need to just rearrange this somehow so that I can write it that way. Now one method that is commonly used whenever I'm trying to prove some identities is that whatever ratios I have, try to write it in terms of only sine and cos. So now this tan square theta, I can rewrite it as sine square theta by cos square theta, and I have minus sine square theta. Then sine square theta is common in both the terms. I'll take that common and I get 1 by cos square theta minus 1. And then I can say that let's simplify this part. 1 by cos square theta minus 1. Denominator you can take cos square theta, and then numerator is 1 minus cos square theta. Again 1 minus cos square theta from this identity is sine square theta. So I get sine square theta into sine square theta by cos square theta. Now sine square theta by cos square theta is same as tan square theta. So I get tan square theta into sine square theta, which is the RHS. So hence I have proved my identity.